Hi everyone. In today's lesson, we're looking at the quotient rule. So as you know, we've already looked at the constant rule. The derivative of a constant is 0. The power rule, the chain rule, right, and the product rule. We've looked at all of those things. Now, if you're starting to get a little overwhelmed and you're worried you're not going to remember these are in the formula booklet. So let me show you that. If you open your formula booklet and you go to topic 5 for calculus, you'll see that we have the derivatives here. We have the chain rule, the product rule, and the quotient rule. And it's just written a little bit differently than I write it, but it means the same thing. For example, if you were looking at the product rule and you had u and v, it would be u times the derivative of v prime, plus v times the derivative of u prime. And we have the quotient rule here. That's what you're going to be learning today. If u is the numerator and v is the denominator, we would have v u prime minus u v prime over v squared. So it is here, so you don't have to memorize any of these things. It's all in the formula booklet. So we're moving on to the quotient rule, and you're going to be using that if you have a quotient, if you have a fraction. So here we go. If you have a fraction and it's the simplest way to approach it, you could use the quotient rule. It would be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. All right, we have some examples. So divide each term of the numerator by the denominator before differentiating, and we're going to compare this result with what we get when we use the quotient rule. So of course, there's a simple way to do this. The quotient rule is a little harder, but I want to use a very simple equation to demonstrate the quotient rule for the first time that you're seeing it. So I want to show you first, if we just simplify this guy and then use the power rule, that would be the easiest way to go. So we could rewrite this y equals x divided into x is 1 plus 6x to the negative 1. All I did was I took x, divided into here, I got 1, and I just rewrote 6 divided by x as 6x to the negative 1. Now I could very simply go ahead and find the derivative. The derivative of 1 is 0 because we know the derivative of any constant is 0. And then I'll take the derivative of the second term. I'm going to get negative 6 and subtract 1 from our exponent, and I get negative 2. So final answer here would be negative 6 over x squared. Now I'm going to demonstrate using the quotient rule. The numerator is going to be f, and the denominator is g. And we're going to write out the rule. So y prime is equal to g f prime minus f g prime all over g squared. And now we'll fill it in. So g is x. F prime is going to be the derivative of x plus 6. So the derivative of x plus 6 is just 1. F is x plus 6. And g prime, the derivative of the denominator, is 1. G squared is going to be x squared. And now we'll simplify that. If I distribute the negative to x plus 6, I'm going to get minus x minus 6 over x squared. So we end up with minus 6 over x squared. So either way works. Of course, we would probably want to do it the first way. But again, I just wanted to show you using a very simple equation how to use the quotient rule. All right, now I'm going to use the quotient rule here first, and then I'll check by simplifying the equation and using the power rule. So we're going to call the numerator f and the denominator g. And the rule says we have g f prime minus f g prime all over g squared. And we'll fill that in. So we end up with, if we distribute the x, we get 4x squared plus x. and then distribute the negatives. So we end up with minus 2x squared minus x. And then combine like terms in the numerator, we end up with 2x squared over x squared simplifies to just 2. Now, the easier way to do it would be to just simplify before we begin taking the derivative. So if I take x and I divide it into 2x squared, I get 2x. And if I take x and divide it into x, I just get 1. Now if I take the derivative of that, we just get 2. So of course we would do the second way if we had a choice, but I'm just demonstrating how to use the quotient rule on something that's a little simpler. So for number 3 and 4, I want you to find the derivative using the quotient rule. I would try both of these on your own, and when you're ready, come back and check your work. We have f, we have g. The rule says that we have g, f prime, minus f, g prime, all over g squared. We're going to fill that in. And we'll simplify the numerator. You don't have to FOIL out the denominator. And final step, we're going to combine like terms in the numerator. All right, and that's it for number 3. For number 4, the numerator is f, the denominator is g, and we'll write out the rule. In the numerator, we have g, f prime, minus f g prime, and that's all over g squared. And we'll go ahead and fill it in. We're going to simplify the numerator. You do not have to FOIL out the denominator. First, we'll FOIL the first term. So we have x plus 3 times 2x plus 3, and we have to FOIL that. And then just be careful, we have a minus the quantity x squared plus 3x plus 1. So when we distribute the negative, it's going to change the sign of every term. So we're going to have minus x squared, minus 3x, and minus 1. Last step, we're going to combine like terms in the numerator. And that's it for number 4. Now on this last page, we've already done this. We did this when we talked about the product rule, but this time we're going to do these types of problems again, but we're going to need to use the quotient rule. So it says find the equation of the tangent to the following curves at the point indicated. Step 1, we'll find the derivative. Step 2, we'll find the derivative for the value given at x. And step 3, we'll use that slope and the given point to write our equation in point-slope form. So first we're going to do step 1, which is find the derivative. We have a quotient, so we're going to use the quotient rule. G f prime minus f g prime all over g squared. And now we'll fill it in. At this point, you don't have to simplify. You can just go to step 2, but I'm going to simplify it first. And now step 2, we're going to take the given value of x, which is 1, and we're going to substitute that into our derivative equation. And that'll give us 1 over 16. Now we have our slope, and we have our point. We can use point-slope form. And so now I have it in point-slope form, so that's great. That's an equation that qualifies, but I always like to put it in slope-intercept form. So I'm going to just keep going here, simplifying this. I'm going to distribute the 1 over 16, and then I'll add 3/4 to both sides. I just think that looks a lot nicer than point slope form, so here's my final answer. All right, one more to try. We have f, we have g. We want to find the derivative, so we're going to use the quotient rule. Go ahead and fill it in. We'll simplify the numerator, and you do not have to FOIL out the denominator. And so we're going to end up with -7 over 2x minus 1 squared. Step 2, we're going to input the given x value into our equation for the slope. So our x value is 2. And when we do that, we get -7/9. So now we have our slope. We have our point here, x1 and y1, and we can use point slope form. We have our equation, but I'm going to keep going and put this in slope intercept form. And that's it for number 6. All done. All right, everyone, have a great day. Thanks for watching.